Bright Tuty. Every student matters.
So that is what we have studied. Now let's move on to the second property, which is reaction with water. Now before we get to this the reaction with water, first let's understand that what is the setup, what is the apparatus that we need to set to do this experiment, to understand how water and metal can react. So to do this, first we have a burner here, as you can see. Then there's a glass bowl which is soaked in water. So what is it doing is that only steam with high energy will be able to reach this metal. So only this water will go from here to here in form of steam, which will be high in energy. So it's indirect heating. Then there's a metal sample kept here. We can use different metal samples. The system is closed with a cork, and through a delivery tube you can see bubbles and you can collect your gas here. When we want to see if this is like hydrogen or not, we can bring a matchstick near it and it will go off with a popping sound. So then we will know that it is hydrogen. Now that we have understood what the setup is, we can take a different metal every time and do this experiment where we will be able to know how different metals are reacting with oxygen with water. So a metal will react with water and it will form metal oxide plus hydrogen gas. Right, so hydrogen gas or H2 gas. So that this metal oxide that is formed can react further with water and produce metal hydroxide. So that is why we will be considering this reaction as a whole, and as you already know by now that potassium and sodium are highly reactive metals, so they even react with cold. So you don't need to have this setup of a burner and steam going away, because they are so reactive that they will even react with cold water and they will catch fire. So it is kind of the interesting thing that will help you remember that potassium and sodium are so reactive that they will even catch fire on being added with water. So that's just a fun thing to know about these elements. Now let's see. So potassium reacts with water to form hydroxide. We've completely combined the equation, and hydrogen and heat energy is formed. Again, sodium would also combine in a very similar fashion. Plus heat. Right, so this is how metals react with water. So you can say that metal plus water essentially leads to the formation of hydroxide plus hydrogen gas. This hydrogen gas we've already mentioned here, so you can do it like this also, that metal plus water leads to the formation of hydroxide and hydrogen gas. Now the reaction of calcium with water is less violent, so it does not catch fire, but it will still react with the water even at room temperature. It will form a hydroxide and it will form hydrogen gas. Now these elements are arranged based on their reactivity. So then we go on to a lesser reactive element, which is magnesium. Magnesium will again react in a similar way, that Mg plus H2O will lead to the formation of MgOH whole twice plus H2. But magnesium will only react with hot water. So the water has to be at a certain temperature for this reaction to occur. Elements like aluminium, iron and zinc only react with steam. So the apparatus that we have set up here, this will be beneficial for other elements. It will again do the job, of course, but they will also react at room temperature or at cold water also sometimes. But this experiment will be especially helpful for understanding the reaction of aluminium and such elements like iron and zinc, because they only react with steam. So we have created steam by heating the soaked wool, and by that we will be able to carry on this reaction. Metals such as lead, copper and silver and gold do not react with water at all. So they are lower down the reactivity series, and that is why they do not show any reaction with water.